Okay, welcome. And today we're going to talk about agreement on the domain. So again, another short video, just to realize that, hey, when we're talking about the domain and the range, it is agreed, okay, in general, okay, so unless otherwise stated, the domain of a relation, okay, again, it could be a function or not, but of a relation is assumed to be all, okay, so unless otherwise stated, the domain of a relation is assumed to be all real numbers that produce real numbers when you substitute in for the independent variable. Okay, so for example, if I have an algebraic function, let's just do this one. Let's do y equals 3x squared plus 2. Okay, so now the domain, again, if we use this agreement on the domain, this idea here, and we say, okay, well, what's the domain? The domain is going to be assumed all real numbers that when we substitute in a real number for x, we get a real number for y. So all the values of x that will give us that is part of the domain. Any values that won't give us that do not result in a real number for y, are not in the domain. Okay? So in this case here, we can obviously see that there are no values of x, there are no real numbers of x that if we plug it in here, we're not going to get a real value of y. Okay? We can plug anything in here. So the domain in this case is all real numbers. So we can write the boldface R for all real numbers, or we can just use negative infinity, comma, positive infinity, or we can just write all real numbers. Okay, depending on, obviously if I ask you for interval notation, this is what you would write, okay? But this would be the example. So, here's another one. What about this one? Okay, well now I've got a square root. Well, in this case, okay, using this agreement on the domain, well, are there any values of x that if I stick them in here, that I can't get something for y? Well, in this case, again, no. Because what can I not have under a square root sign? I can't have negative numbers. Now, are there any values of x that will give me a negative number under the radical in this case? No. Okay, so again, this would be all real numbers as the domain because there's no value of x that I can stick in here that will give me a problem for y. Okay, but what if I do this? What if I change it to this? So now it's 3x plus 2. Now, we do have a problem, or can have a problem. So again, what can we have under the radical? Okay, square roots or even roots, we can have only non-negative values as the radicand. Okay, so the radicand is everything under the radical. Okay, so this has to be non-zero, so it has to be 0 or positive. So if we solve this under the radical, 3x plus 2 greater than or equal to 0, let's solve for what values of x is greater than or equal to 0, then we get x is greater than or equal to negative 2/3. Okay? That means that only values of x that are greater than or equal to negative 2/3 will work. Anything that's less than negative 2/3 will give me a negative number under here, so that means the domain for this relation is this. Okay? So that leads to the general application of this. So the takeaway is, in general, the domain of a relation is all real numbers except any values of x that lead to either a 0 in the denominator if you're talking about a rational expression, or a negative number under an even root. Okay? So if we're talking about even roots, then any value that leads to a negative number under the radical is restricted, so they cannot be in the domain. So in general, if you have an algebraic expression, so the domain of any algebraic expression is all real numbers except any values of the independent variable that lead to either 0 in the denominator, which we can't have, or the even root of a negative number. Okay, so that's it. Okay, until next time, have a good day.